Bismillahirrahmanirrahim. Assalamu alaikum. In today's discussion, we will focus on factorial ANCOVA. What is the difference between simple ANCOVA and factorial ANCOVA? If you want to learn more about simple ANCOVA or one-way ANCOVA, you can watch my video lecture on ANCOVA. And its related tests are also available on YouTube channel. So you can watch them in detail. But in today's lecture, in this discussion, we will be focusing on factorial ANCOVA. What is the meaning of factorial ANCOVA? Actually, let me show the file, the data file which we are using for today's discussion, for today's analysis of factorial ANCOVA is credit card. And this data file is available in the SPSS. You can easily use this file from your program files from C drive. Well, we are using it, and factorial ANCOVA is actually how to use it. We use analyze and then general linear model, univariate. And in univariate, the variable which we are using is actually the items as the covariate, the number of items, because we assume that if the number of items which are to be purchased against 5 credit card, the type of card, then the total expenditure also increase. So total number of items actually push up or put pressure on the amount of expenditure. So we are using credit card as a fixed factor or a categorical variable, and item as a continuous variable, and our dependent variable is total spending. Now, what is this is if we are using this much, then we will be focusing on simple ANCOVA. But our is case in today's lecture of factorial ANCOVA. So factorial ANCOVA, actually we need to add one more moderating variable here, gender. So gender has 2 categories. So controlling for 2 types of gender, what is the relationship, what is the extent of relationship between card and spending and number of items, and the relationship between items and the amount of spending. So, so these two, so basically we want to see whether gender moderates the relationship between card and spending, between items and spending or not. So such type of analysis is known as factorial ANCOVA. What options we need to select? We go to options, and all of these here we need to select. So overall card, gender, and then card into gender. And obviously, since post hoc cannot be applied, so as an alternative to the post hoc, we will be choosing Bonferroni, which actually compares the average expenditures on each card with the rest of the cards. So descriptive stats mandatory because we want to know the actual amount, and then observer, the estimates effect, eta square will be calculated for this purpose, and the parameter estimates are essential because we want to see the extent of relationship and the role of moderating variable gender. Homogeneity is mandatory because of ANCOVA, ANOVA, and all such type of tests require us to estimate Levene stats. So that is mandatory. So we continue. And next is if you want to select the model plots, if you want to plot, well, okay, we can put card on horizontal and separate line for separate lines here, and we add it here. So card and gender is recorded. Well, we continue and we for the selection of model custom and all these say card this, for example, we want to see their main effects. So for the calculation of their main effects, we will be selecting all of them, and then there, for example, the moderating role of gender and item as interaction effect. So as an interaction effect, gender items, and then interaction effect between card and gender. We shifted here. So now try to understand why we are shifted here, because we are assuming that gender plays the role of moderator between the relationship of card and the dependent variable, between items and the dependent variable. That is why we have included two product term. So every independent variable multiplied by gender. We continue. And anything else we want to save? Yes, if you want to check the heteroscedasticity, then you can save a few statistics. For example, for that matter, you need to save y hat, which is the estimated value of the dependent variable spending, and then mu hat unstandardized and standardize the z value of the mu hat, or the stochastic variable y minus y hat according to the language of econometrics. It is the z distribution of the mu hat. So continue. Anything else here? Contrast, perhaps at this stage we are not using any contrast. Options have already been selected. So this is the specification for Factorial ANCOVA. Okay, so these are the results. So how to read them? First, information about the variable. For example, the primary card, 1, 2, 3, 4, 5 categories of the card. And then gender, male, female, 2 categories. And what is their sample size? This is very important to know, particularly when your Levene test is rejected. So for the robustness of the test results, the assumption is that the sample size across these categories should not differ much. So descriptive stats, simple average expenditure. For example, average expenditures against American Express in case of male are 238, in case of female 233, and total are 236. Similarly, for the average expenditures on visa, in case of male 207, in case of female 227. So it means generally females spend more if they are more than male, if both of them are holding visa card, if both of them are using visa card. But in case of American Express, generally male spend relatively more amount than female if both of them are holding American Express, and this is how you will proceed. Then Levene test for the purpose of testing homogeneity, heteroscedasticity or homoscedasticity. So it proves heteroscedasticity. Why? Because the null hypothesis of homogeneous variance of expenditures across these 5 categories of card is rejected. The null hypothesis of homoscedasticity is rejected here. And the other things, for example, the size of effect, which is measured from partial eta square. So which one is the highest? The guideline of Cohen. According to Cohen's criteria, 1% is the small size, 6% is the medium size, and 14% or above is the bigger size. So it means the number of items have significant impact on aggregate expenditure. So if the number of items increase, the expenditures increase significantly, and the effect size is also much, much bigger. As per Cohen's guidelines, it is 75.3%. And the large size is actually 14 maximum, and then if it exceeds, so it is the highest level. And then the R square value, adjusted R square value again, 76.2%, which means 76.2% of the variation in spending is explained by the independent variables included in the model. And the parameter estimates here, individual significance. We look at T stats. So using the rule of thumb, If the absolute value of t is more than 2 or equal to 2, that value is significant. Or reading from the level of significance, the probability which the guideline, according to the guideline of the statistician, less than 5%, 5% or less than 5% actually proves the significance. So card number 3 does not significantly differ from the average expenditure. Actually, how to read it? Average expenditures on card number 3 are not significantly different. So it is not significant. But as far as expenditures on card number 1, significant. Card number 2, significant, significant. Now, how to compare? Now, when you are using a moderating variable, then individually, yes, they are significant, but you have to look at the product term. For example, because gender is playing the role of moderator here. So if gender multiplied by items is significant, then gender is a good moderator. But here in our case, it is not significant. It means in case of number of items, it does not matter whether male are spending or female are spending. There is no much difference or statistical difference between the average expenditures on various items as far as gender is concerned. So, but if you, for example, look at the gender equal to 1, so 1 is for female. Female is used as a reference point because it is being multiplied by here and there is no value, so female is being used as a reference point. Let's see whether female assumed 0 or 1. From here we can verify Control T, and the gender here 0 is for, sorry, 0 is for male and 1 is for female. So the code with 0 is used as a reference point in the analysis. So let's go back to our results. So here male is being used as a reference point, so but it is not, you know, so this will be the value of female as compared to male. So it does not make any difference whether it is male or female. The average expenditures on different items does not vary much. Similarly, the other product term are also explained in the same way. Now, when gender is multiplied with card, is it significant? Yes, card number 1 is significant. It means female card holder of card number 1 spend significantly different from their counterpart male, because male is being used as a reference point. And here is this 0, it is being used as a reference point. So 1 and then reference point 1, the other is being reference point. So for example, gender 0 is for male and 1 is for female. So female is being used here as a reference point because its value is not given here. Whether it is significant, no, it is not significant because it is 5%. So whether card number 2 is held by male or female, the average expenditures do not significantly differ from each other. But in case of card number 3, definitely there is significant difference. So male are generally spending more than female. So this is how we can analyze, we can further proceed. So as a whole, whether gender moderates or gender does not moderate the relationship of card and spending, items and spending. So we can say, how can we decide? If you look at the product term, for example, gender multiplied by items, it is not significant. So it means gender does not moderate the relationship of items and spending. And card and gender, yes, here that as far as different types of credit cards are concerned, gender plays a significant moderating role either it strengthens the relationship or weakens the relationship. So it is a strong moderator over there. But the effect size, it is a moderator. Whether the effect size is mentionable or not, it is not mentionable. The effect size is not so big. But as far as moderating role is concerned, it plays very important moderating role. Then the other things are, as usual, the average expenditures adjusted after the adjustment, after the incorporation of covariate, the effect of covariate, the adjusted value of the average expenditure. Then the other test is, this one, Bonferroni test, which compares the amount of expenditure across different categories of the cards, credit cards. If it is significant, there is significant difference between the average expenditures on American Express and Visa versus MasterCard, Discover, and other. So American Express, as compared to each of these category, significantly different from each other. Their expenditure, the expenditures on these cards are significantly different from each other. The F-test is significant, which means the variables included in the model, they do affect the dependent variable spending, but their effect size is just 1.3%, which is ignorable. So this is how we can analyze, and graphically the same thing is here. So thank you very much. If you want to analyze the, if you want to learn or investigate in detail the presence of heteroscedasticity, you can apply more tests or you can watch videos related to the measurement, detection, remedial measures of heteroscedasticity. So thank you very much.